Alright class, today we're doing sum and difference, verifying with sum and difference identities, our formula. So what we're doing is we're basically doing our identities again, our proofs that we were doing before, but with this formula. It actually makes it easier. Okay, so we're going to use the formula to expand it and then show that it equals the other side. So again, there's your formulas. So we're going to use the sine formula first with a plus. So I'm going to work this side because this is the one I can expand. So this becomes sine of 3 pi over 2 cosine of theta plus cosine of 3 pi over 2 sine of theta. Okay, so now we are trying to simplify this side to get it to look like that side. At 3 pi over 2, that's 270. That sine, or the y, is -1. Cosine of 3 pi over 2, if sine's 1, cosine has to be 0. And sure enough, this piece will go away because 0 times sine is 0, and you get -1 times cosine, which is negative cosine of theta. So we did it. So these identities are actually easier because if you see a sum of angles, use the formula to expand it, and then it generally works itself out. Alright, we got one more today. This should be a quick note today. It's just an extra little something to double check. So if I look over here on number 2, I'm going to work this side, and if I look, I want to expand the top because there is my difference of two angles. Remember, when you do cosine though, you're going to use the opposite sign. So if I expand this, I get cosine alpha cosine beta plus sine alpha sine beta all over sine of alpha cosine of beta. And that's going to equal this. I'll just keep bringing that down. Now, remember, when you have a plus on the top, but not like just one term, one big term on the bottom with just being multiplied together, you can split these into two fractions. That is a very key thing to be able to do when you're doing identities. So for example, I can say that I have cosine alpha cosine beta over sine alpha cosine beta plus, and then the other piece is sine alpha sine beta over sine alpha cosine beta. Alright, now I simplify this. In this fraction, I have the cosine betas cancel, and I'm left with cosine over sine, which is cotangent of alpha. Because they're both the same angle, I can do that. Over here, the sine alphas cancel. I have sine beta over cosine beta, which is tangent beta. And sure enough, if you look back at the top, that is what I wanted. So really the only tricky thing here was remembering you can split your fraction into two with the same common denominator. Okay? That is how you do identities with sum and difference. Basically work the one that you want to expand, and then you're good to go.